Chapter 8.5 Annuities Present Value Part 1. The goal of this lesson is to determine the present value of an annuity earning compound interest. In the previous lesson, you should have learned that annuities are investments made at regular intervals over a period of time. Many people buy annuities to earn guaranteed income, but it is much more common among people who are retiring. You should have also learned about present value, which is the principle that would have to be invested now to get a future value in a certain amount of time. We will apply this to annuities in the examples that we will solve today. The formula for present annuities is PV equals R 1 minus 1 plus I raised to negative n divided by I, where present value is represented by PV. R is the payment per period, I is the interest per period, and N is the number of periods. You will understand this by solving the examples. Rick pays $20 for a DVD player and borrows the remaining amount. He plans to make 10 monthly payments for $50 each. The interest rate is 15% per annum compounded monthly. What was the selling price of the player? In this, we will use our formula that we saw in the previous slide. So, we do have our R, I, and N, and we need to find our present value. So, PV equals $50 is our R, 1 minus 1 plus 0.15, that is our compound rate, 0.15 divided by 12 as there are compounded monthly, and raised to negative 10 as there are 10 monthly payments, divided by 0.15 divided by 12. So PV equals 50, 1 minus 1 plus, if we divide 0.15 with 12, we get 0.0125 raised to negative 10 all over 0.0125. So PV equals 50 times 1 minus 1.0125 raised to negative 10 divided by 0.0125. If we plug it all into the calculator, then we get PV equals 50 times 9.345525907, and therefore if we multiply it by 50, we get 467.276. So that is our present value, although that is not the selling price of the player. So in order to get the selling price, we need to add $20 to our present value, as they were paid before borrowing these money. So let's say the selling price is S equals PV plus 20. So S equals 467.276 plus 20. So S equals 487.276. Therefore, our selling price is $487.28, just to round up. So, the second part of the question is that how much interest will he have paid over the term of the loan? We will do this using A equals R times N. We do know that R is the payment per period and N is the number of periods, but A is the total amount including the rate of interest. So, A equals R, that is 50, times N, that is 10. So A equals 500. So now if we think practically, then this is the amount including the rate of interest. So now our present value, that is P, is the amount excluding the rate of interest. So now if we subtract P from A, then we can get our I, that is the interest. So I equals 500 minus 467.276. Notice that this is 467.276 and not 487, that is the selling price, because that is including the extra $20. So I equals 32.724. Therefore, the interest is $32.72. John borrowed $30,000 from the bank to buy a car. If the bank charges 3.3% interest compounded semi-annually, how much does John need to deposit twice a year in order to meet their goal? In this question, we are provided with the present value, that is $30,000, but we do not have our R. So 30,000 equals R 1 minus 1 plus 0.033, that is our rate of interest, divided by 2 as it is compounded semi-annually, raised to negative 2, divided by 0.033 over 2. So 30,000 equals R 1 minus 1 plus 0.0165 raised to negative 2 divided by 0.0165. So 30,000 equals R 1 minus 1.0165 raised to negative 2 divided by 0.0165. 30,000 equals R. If we plug in all whole number into the calculator, then we get 0.03322000855 divided by 0.0165. So now 30,000 equals R times 1.951566,975. If this number is divided by both the sides, then we will get R equals 30,000 divided by 1.951566,975. So our R equals 15,372.2 26259. Therefore, John will need to deposit $15,372.26 in the bank twice a year in order to fulfill his loan of $30,000. Part B of the question says, how much interest will John have paid over the term of the loan? So it is using the same formula as the previous one. A equals R times N. A is the total amount including the rate of interest. So A equals R that we just found, 15,372.26259 times 2. So A equals 30,744.5251782. So now we need our interest that will be found by subtracting the present value from the total amount including rate of interest. So I equals 30,744.5251782 minus 30,000. That is the present value. So I equals 744.5251782. Therefore, John will be paying $744.52 as the interest to the bank. Thus, in a snapshot, the present value is the amount of money you will need to invest in an annuity in order to get free money for the future through the interest and the time period you keep that amount in the bank. The more the time period, the more the amount you'll get back.